All right, good morning, mathematicians. Um, First of all, I'm so sorry that I'm not here today. Not feeling the best, so I decided just to, take it easy and try to get better, and that way I can get back to you guys as soon as I can, so I apologize. There is one major announcement that I have to make. I'm sure that the substitute also told you guys this, but I want you guys to make note. Actually, here, let me write this in a more daring color. Your test, your unit test, is on Friday, this Friday. That is September 27. Okay? So everything that we've covered so far, the mean, the mode, the median, the range, drawing line plots, drawing box and whisker plots, and then today's lesson, of course, is going to be on that test. Okay? I need to remind you guys that the test is closed. That means you cannot use your notes. So you must be studying a little bit every day up until the day of the test. Okay? You guys need to be practicing. You guys need to ask questions. You guys can always come see me during RAM. Okay? Please just be studying at home. That is part of your homework now for this week. Study at home. Practice at home. 5 minutes, maybe 10 minutes if you're really struggling, okay? But no more than that. That's all I ask, okay? So again, your test is this Friday on September 27. All right, let's go ahead and dive right into our lessons for today. Buckle your seatbelts because we're going to take a look at another type of graph. Our focus question: how can you use a histogram to help you interpret data? Yes, that was histogram, not Instagram. They are very different things. So if we take a look at the definition of what a histogram is, it's a display or it's a graph that shows the distribution of numeric data. So what's nice about histograms is that you draw one, then you can tell me the distribution of the data. Is my data skewed left? Is it skewed right? Or is it symmetrical? Right? So that's what's so nice about a histogram, is that it actually can show us visually the distribution of our data. Okay? And the way that histograms are drawn are these things that we call intervals, which is a group of consecutive numbers. Take a look at the histogram over here on the right side. So I'm going to draw lines at my interval. So I started at 60, and I went up to 65. What's the size of my interval there? Hopefully you said 5, right? 60 to 65, that's an interval size of 5. Let's check the next one. What's 65 to 70? Also 5. Okay, let's check one more. What about 70 to 75? Okay, yes, you convinced me. It's 5. So can we answer this question? What is the interval of this histogram? It is 5. Okay. All right, so we're going to be making our own histograms today, and we have a nice step-by-step process here. So instead of just reading this out loud to you guys, instead what we're going to do is we're actually going to go through the steps and make a histogram of this data right here, and this is on page 34. Okay, we're going to save these two questions for after we draw our histogram, okay? So let's take a look at this data here. So this table tells us the time it takes for these students to come to school. So we're specifically looking at this column right here, the travel time in minutes. Okay, so the very first step to creating a histogram, you have options here. You can either create a line plot or a dot plot of your data, or you can make a frequency table of your data as well. In my personal opinion, it's a lot easier to make a frequency table, okay? So we're going to do that. First, let's read the directions so that way we do everything correctly before we start. It says to make a histogram that displays the travel time data, and we're going to use an interval size of 5 minutes. So let me make a quick little t-chart over here on the right side. Boom. And boom. Okay. So the left column is going to be my travel time. And then the right side of my column is going to be the number of students, right? However many students fit that travel time, okay? So remember, they want an interval size of 5. So my first travel time is going to be from 0 to 5. So I'm looking for the numbers between 0 and 5, but not including 5. I'm going to repeat that again. I'm looking for numbers that are between 0 and 5, but not including 5. Are there any numbers in this data set between 0 and 5, but not including 5? Hopefully you said no. There are 0 students between 0 and 5. Okay? And the reason why we're skipping 5 is because 5 is going to be included in our next time interval here, which is 5 to 10 minutes. So I'm looking for numbers between 5 and 10, but not including 10. Okay, so let's count in my table. I have 1, 2, 3, 4, 5, 6. I have 6 students between 5 and 10, but not including 10. All right, let's keep going. 10 to 15. That's my next time interval. I need students between 10 and 15, but not including 15. So let's count them. I have 1, 2, 3, 4, 5. There we go. Let's keep going. 15 to 20 is my next time interval. I'm looking for students between 15 and 20, but not including 20. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And our data continues on the next table over here. So we're at 9, 10, 11, 12, and I think that's it. Yep, we're at 12. Okay, let's keep going. Next time interval is 20, whoops, I skipped. It should be 20 to 25. I'm looking for numbers between 20 and 25, not including 25. So that's 1, 2, 3, 4, 5, 6, 7, 8. So 8 students take between 20 and 25 minutes to get to school. Next interval is 25 to 30. I count any numbers between 25 and 30, but not including 30. So that's 1, 2, that's it. So there are 2 students. Keep going up. We're going 30 to 35, not including 35. So here we have 1, 2, 3. Okay. Next interval is 35 to 40. I count 1, 2. And we're not skipping intervals here, you guys. So we need to go 40 to 45. I have 0. I need to go 45 to 50. Right? Am I including 50? Hopefully you said no. So we're still at 0. We're going to go 50 to 55. Ah, there we go. Now we can count that 50 there. 50 to 55. What about 55 to 60? Am I including 60? Hopefully you said no. So we're going to write 0. And then we need one more. We're going 60 to 65. And then we can finally include this final number. Whew, there we go. So we just created a frequency table. That was step 1. And actually we determined the frequency. We did step 2 in it as well. So cool. We knocked 2 birds out with 1 stone. Awesome. Okay, so now the third step is finally creating this graph. So along the bottom, where it says time in minutes, we're going to start on the very, very left side. So just like this, we're starting at 0. And I need to go up all the way to 65. And I'm going to go by increments of 5-minute intervals. So I go from 0 to 5 to 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. And I'm going to go ahead and label all of those. So these are all important for drawing our histogram, okay? So all of these steps are necessary. Okay, now we need to label the left side. I'm sorry, I'm probably going really fast here. So if you go ahead and pause the video if you need time to catch up labeling the bottom of your graph. Okay, now we're going to label the left side. So what is the most number of students we had? Well, I see a 12 in my graph, or in my frequency chart. So I'm just gonna label all the way up to 12. So I actually think it might be beneficial to go up by 2s. So that's 2, 4, 6, 8, 10, and then at the very top, 12. There we go. And if it helps you, you might want to put tick marks in between so you can find your odd numbers. Just like that. Okay, so here we go. Here is where we start drawing our histogram. So we're just going to go down the frequency chart. So looking at this, we're just going to go down the frequency chart. So for a travel time of 0 to 5, I had 0. So I'm going to leave it blank. I'm not going to draw anything there. For 5 to 10 minutes, how many students did I have? I had 6 students who took 5 to 10 minutes. So what I'm going to do is I'm going to create the sides of my bars. I'm going to go all the way up to 6. Creating the sides of my bars there. All the way to 6. Then I'm going to connect them. And there we have our first bar of our histogram. Cool. Let's keep going. So I did 5 to 10, so I'm good there. Let's do 10 to 15. 10 to 15, there were 5 students. So I'm going to create my right side of my bar here. There we go. All the way up till 5. And then do you see how the 5-10 bar actually became part of the 10-15 bar, right? They're kind of squished together. There we go. And then we're going to keep going. If you guys know what to do, just keep going on ahead. You don't need to wait for me. If you're stuck, go ahead and follow with me, please. 15 to 20. We are all the way up at 12. So what I might do is I might just start a line at 20, go all the way up till 12. There we are. Draw a line from 15 all the way up till 12. There we go. And then connect your bar. Just like that. Okay. 20 to 25 is next, and we have 8 students. So drawing the side of my bar all the way up to 8. There we go. And remember, you guys, it doesn't need to be absolutely perfect, okay? Just try your best, try and make it as accurate as possible, but again, it doesn't need to be perfect, okay? So don't stress yourself out. 25 to 30, we have 2 students, so we're going to draw a line all the way up to 2, not very tall. There we go. 25 to 30 is done. 30 to 35, there are 3 students, so draw a line all the way up to 3, just like that. Then connect your bar. There we go. 35 to 42, it's also at 2, so that's nice. We can kind of just copy that line there. Good, we're at 35 to 40. Now we're at 40 to 45. Hey, look, we have 0. 45 to 50, we also have 0. 50 to 55, so we're leaving those gaps there. So this is at 1. Okay, 55 to 60, we also have a gap. And then at 60 to 65, we should include a bar at 1. And there we go. Now we have a lovely histogram here. Now, remember at the beginning of this lesson when I said that histograms show us the distribution? So I'm going to draw my roller coaster. My roller coaster is going to travel all the way up like this. And then we're going to go down all the way to just like this. Okay, now I want you guys to think about this. How would you describe the shape of this distribution? Is this data skewed left? Is it skewed right? Or Is it symmetrical? Pause the video. Let's talk about it. Okay. Hopefully, you guys said that this graph is skewed right. This graph is definitely skewed right. So remember that we always look at where the tail end is, or where there's not a lot of data, right? So notice how there's not a lot of data here on the right side. Not a lot of data. There's not a lot here on the right side. So because it's lower on the right side, we say that this graph is skewed right. Because my tail end of my data is on the right side, it is skewed right. Okay, and there we go. There we have how to create a histogram, right? Create your frequency table, create your number lines on your graph, and then go ahead and draw your bars. Now, I want you guys to take a moment. Talk with your elbow partners, please. How is the histogram like a bar graph? How is it different? Okay, what's the same? What's not the same in terms of a bar graph? Okay, and we're actually going to talk about this when I see you guys on Wednesday. Okay, so talk about it for about 2 minutes. What's the same? What's different? And write your answers on page 33. Okay, so right underneath question number 1. All right, go ahead, pause the video, talk about it. Go ahead. All right, so now we're getting into the independent practice part of your histogram drawing. So what I want you guys to do is you're going to spend about maybe 4 to 5 minutes answering these questions on page 35. Only the first 5 questions, please. Okay. Use this graph on the left to help you answer the questions. So go ahead, pause the video, work for about 4 minutes. All right, hopefully pause the video. So we're going to practice reading this. How many players play baseball? So you're looking at the baseball graph here. It looks like it's in between 70 and 80, so we're going to say that 75 players play baseball. Which game is least popular? You're going to look at the lowest graph, which is tennis. Sorry, tennis players, which is at 60. So I'm going to write tennis. Not tennis. Tennis. There we go. What is the difference of players playing tennis and basketball? So we need to find out the number of players playing basketball first. So I'm looking over here. That looks to be about 80. And we're looking for the difference. The difference tells me to subtract. So the difference between tennis and basketball, well, 80 minus 60 gives you 20. A difference of 20. All right, how many players play football? So we're looking at that last bar of our histogram. That's in between 80 and 90, so we're going to say 85 players. Now, the last question, which game has more than 80 players? Well, the only sport that has more than 80 players is football. Okay, so now we're moving on to the second part of our independent practice here. Okay, we're going to create our own histogram from this data here. Okay, when you guys are creating your frequency table, I need you guys listening to this, please. When you're creating your frequency table, notice these intervals. Okay, so 40 to 44. I am going to include 44 because if you look at my next interval, where does it start? It starts at 45. So I have to include 44 in my previous interval. Okay, so let's fill out the first few together. So 40 to 44, do you see any temperatures that are the numbers 40, 41, 42, 43, or 44? Nope, I don't see any. So the number of values is going to be 0. Okay. Next, I'm looking for the numbers 45 to 49. I am including 49 again because if you look at my next interval, it starts at 50. So I need to include 49 in this previous interval. So let's go ahead and count. 45 to 49. I see a 48. I see a 46. I see a 49. I see another 46. Nope, that's it. So I say there are 4 values from 45 to 49. Let's do one more together. From 50 to 54, let's go ahead and count those. So I see a 52. I see a 50. 55 is too big. 57 is too big. I see 53. I see a 50. 56, nope. 55, nope. 51, 53, 56, 59, nope, 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 nope. I think that's it. I have 1, 2, 3, 4, 5, and 6 for 50 to 54. Okay, I think you guys know what to do now. So I want you guys to pause the video for about 8 minutes, maybe 10 minutes, okay? Fill out the rest of your frequency table, and then go ahead and graph your histogram. Work together, please. Ask each other questions. You can always ask Miss Diana questions as well, okay? Go ahead and get to work. All right. Hopefully, you guys finished your histograms. So take a look. This is what we should have here. So notice that the shape of this distribution, I don't know, I'd say it's definitely more symmetrical, but I did have, so I like this, symmetrical, definitely. But I did have a student the other day say that it kind of looks a little skewed right to me. And I said, is it like insanely skewed right? Is it skewed right a lot? And then they said no. And I was like, okay, so can we write slightly skewed right? And then they were like, okay. And I said, okay, that's fine too. But I think you guys, this is more symmetrical than it is skewed right. Okay. All right. Awesome work. We're going to keep going. We have one more lesson to do together. So let's take a look. Meet me on page, I think it's 38. Page 38. There we are. And we're going to complete question A together. Okay, so please hang in there. This is the last thing that you guys are going to need to know before your quiz or before your test. Yes. Am I correct? Yes, I am. Yes, this is the last thing you're going to need before your test. Okay, so let's take a look. I'm on page 38. Sorry if that made you dizzy. I didn't mean to. I'm sorry. Okay, so it says, how can you compare, our focus question says, how can you compare and contrast data represented by dot plots, histograms, and box plots? So what's nice about having these 3 different types of graphs is that they all tell us different information, right? Some give us more information, others give us more information about other things, right? So it's up to us to figure out when is it good to use dot plot, when is it good to use a box and whisker plot, and when is it good to use a histogram. So what I want us to do right now is we're going to label these. This graph right here with all the dots, hopefully remember that is a dot plot. Okay. The graph over to the right with a box, hopefully remember is a box and whisker. That is a box and whisker plot. And then the last graph, well, we just talked about it. This is what we call our histogram. Okay. So here's what we're going to do. We're going to go question by question. You guys are going to pause the video. You're going to talk about it with your elbow partners or your groups to come up with an answer. Okay? And then maybe after about a minute, maybe 30 seconds to a minute, we're going to talk about the different graphs that we used. Okay? So question number 1, it says use one or more, that's important, one or more of the graphs to find the number of students in the group and explain your reasoning. So we are looking for the number of students in the entire group here. So go ahead, pause the video, talk about which graph would you use to tell you this information. Okay, so hopefully you pause the video. I am sure that some of you guys said dot plots. And then why would you pick a dot plot? Well, you can just count the dots, right? You count the dots, and that tells you how many students are in this data set. So you count the dots. Now, some of you might have also said a histogram, right? The histogram shows us how many students said this range of answers, right? So for example, the students that are 58 to 60 inches tall, it's halfway in between 10 and 5, so they're probably around 7, maybe 8 students, right? So we can also use the histogram to tell us how many students took this survey. So the bars tell us how many students, and then we just add up all the numbers. You add all the numbers to find the total number of students. Okay. Question number 2. What do you notice about the data values and their distribution? Keyword, and their distribution. Well, that was words. Distribution is what I was pointing towards. So what do you notice about the data values and their distribution? Which graph do you think is most useful when describing the distribution? Go ahead and pause the video, talk to your partners, please. Okay, so the definition of this graph is that it is a graph that shows the distribution of a set of data. So hopefully you guys said that a histogram would be the best graph. And the reason why this is because it physically shows us what the distribution looks like. What the distribution looks like. Okay, let's keep going. Describe any clusters or gaps in the distribution. Explain which graph is most useful for identifying clusters or gaps. Okay, take a minute. Talk about it with your elbow partners, please. Which graph would you use to describe clusters or gaps? All right, so I think some of you guys said, I hope some of you guys said, the dot plot. I want to take a look at the dot plot now. So, do you see any gaps in the data? Do you see a number where there are no dots? I'm sure some of you guys noticed that we're missing a dot here at 72. This right here is a gap, right? There's no data there. And I really wish I could be there to talk to you guys about this, because my follow-up question would be, well, where is the cluster then? Where is our data clustered? So I'm sure that some of you guys notice that your data is clustered all the way from 56 all the way up until 71. This is our cluster. I can spell. This is our cluster right here, where our data is grouped up and bunched together, where there are no gaps in between. So from 56 to 71, there's a cluster from 56 to 71. Then there's also a gap at 72. Now, the reason why the dot plot shows us this is because we literally see all the individual answers, right? They're all laid out there for us to see. Okay, let's talk about the spread of the distribution. So when we talk about spread, there's this thing that we calculate, that we have calculated actually before, that means the same thing as spread, right? How spread out our points are, how spread out our data is. If I were there, I'd ask you guys to take guesses, but for right now, we're talking about the thing called range, right? So we're going to describe the spread of the distribution here. So I think the best graph that we can use that shows us the range is going to be our box and whisker plot over here, right? The box and whisker plot shows us our minimum value, and then we have our maximum value over here. Oh, I ran out of paper or space. This is our maximum value. So the box and whisker plot shows us a visual representation of how spread out our data is. So we're at 73, and then we subtract 56 for our range. I'm going to borrow here. So our range is equal to 17. And there we go. Okay, which data value occurs most frequently? I think you guys would look specifically at your dot plot here, right? It's asking for which data value occur frequently. So you would look at the dot plot and you'd probably notice, hey, look at that. I have a bunch of 62s, right? So 62 would be a data value that occur frequently. Which ones occur infrequently? Well, you might say that all of these little ones occur infrequently, right? So that's 56, 69, 70, 71, 56. I already forgot which numbers I said. 56, 69, 70, 71, and I believe 74. Or no, 73, excuse me. There we go. Okay. How close together are the data values? Now we need to ask ourselves, which graph would we use to figure out how close our data is together? So take a second, talk to each other, please. Which graph would we use, the box plot, the histogram, or the dot plot, to figure out how close my points are together, how close my data is together? All right, hopefully you pause the video. I would say that the dot plot tells us this. Right? The dot plot shows us all the individual dots or all the individual data values, and we can see how close together they are, right? Are they clustered? Are there gaps? Okay, let's keep going. Now, explain which graph is most useful when describing how the data vary. Now, this is another keyword. Remember, vary also talks about the range. So which graph would you use to help you find the range? We already talked about this. This is our box and whisker. Except I want to ask you guys, is there another graph that shows us the range? Is there another one that you could use? Think about that for like 10 seconds. Which graph would you use to describe how the data vary? So some of you might have said the dot plot, right? Because on the dot plot, you can actually see the highest value and the lowest value. So you could also take a look at the dot plot there. But I would definitely look at the box and whisker first. Okay, so question number 5 is going to be something we're going to save for Wednesday, okay? So we're going to be talking about how the dot plot, the histogram, the box plot are the same, but more importantly, we're going to be talking about how they are different from each other, okay? So I am so proud of you guys. You guys hung in there. I will see you guys on Wednesday. Don't forget, we have minimum days starting tomorrow and Wednesday, okay? So we're going to have a little bit shorter time together. But that's it for our lesson today. Please let me know if you guys have any questions, and I will see you guys in the next video.